Hey everyone and welcome back to Skip Uni. So इस लेक्चर में हम C++ और Java में फाइनल कीवर्ड के बारे में सीखेंगे। मैं एक्सप्लेन करूंगा कि फाइनल कीवर्ड क्या होता है, इसका यूज इनहेरिटेंस और मेथड ओवरराइडिंग को रिस्ट्रिक्ट करने के लिए कैसे किया जाता है और Java वर्सेस C++ में इसका क्या डिफरेंस है। अगर आप ऊप्स इन C++ या कॉम्पिटिटिव एग्जाम्स और प्लेसमेंट इंटरव्यूज की तैयारी कर रहे हैं तो ये लेक्चर आपके लिए बहुत इंपॉर्टेंट है। Seriously, I am so pumped to dive into this with you today.
Now, you might be wondering, why on earth are we dedicating a whole lecture to just one single word? Well, here's the secret. The final keyword is an absolute favorite for technical interviewers. Whether you're targeting top-tier tech giants or just want to make your object-oriented programming fundamentals rock solid, nailing this concept is going to pay off big time during placements. Interviewers don't just want to see if you know the syntax, they want to know if you actually understand the philosophy behind your code.
Okay, so here's our quick roadmap for today. First, we'll hit the core concept, then look at restricting inheritance, move on to preventing overriding, tackle the C++ versus Java debate, and finish up with a solid summary.
All right, let's jump right into Section 1, the core philosophy of final.
So why did the creators of these languages even introduce this keyword in the first place? Well, the whole game of the final keyword boils down to one powerful concept: restriction, or as we say, rukna. When you're building complex software, you really don't want your code to be endlessly flexible. Sometimes you absolutely have to set strict boundaries. You're basically telling the compiler, hey, stop right here. Nobody is allowed to modify, override, or extend this code anymore. That's the real magic of final. It brings some much-needed security and predictability to your object-oriented architecture.
Moving on to Section 2, restricting inheritance in C++.
Let's walk through the logic of how a developer actually builds classes. Normally, you've got a base class, your superclass, and you create a derived child class from it, right? It's just standard inheritance. But what if you want to lock that base class down completely? Step 1, you create the base class. Step 2, you slap on that final keyword. Step 3, some other developer comes along and tries to create a derived class from your secure base class. And step 4, bam, the compiler steps right in and shuts them down with an error.
Let's look closely at the actual C++ syntax for a second. We write class base, and then right after the class name, we just drop in the keyword final. Then we open our brackets and define the class, like throwing in a public void show function. Just by adding that one single word, final, right there, you've completely locked the whole class down. It is literally impossible to inherit from now. And here's where the magic happens. If you go ahead and try to write a derived class inheriting from that public base class, your program isn't even going to compile. No way! You'll instantly get smacked with a hard compiler error saying you cannot inherit from a final class. The compiler is literally acting as a bouncer, enforcing that architectural boundary you just set. It's such a fantastic tool for protecting the core logic in your apps.
All right, let's look at Section 3, preventing function overriding.
To really get this, let's do a super quick recap of the default behavior. In runtime polymorphism, your base class usually has a virtual function, and normally a derived class is going to override that function to do its own specific thing. So if you make an object of the derived class, it outputs the derived version and totally ignores the base version. But what if we don't want that? What if we have a super sensitive function in our base class and we want to permanently freeze it so no child class can ever mess with it?
Well, this is exactly how we solve it. Inside your base class, when you declare that virtual function, like our void display function here, you just tack on the final keyword at the very end of the function's signature, right before the opening brace. By doing this, you're explicitly telling the compiler, listen, this is the ultimate, final version of this display function. Nobody is allowed to touch it.
And just like with the class inheritance we saw earlier, this restriction is completely ironclad. If someone creates a derived class and tries to write their own void display function to override yours, the compiler catches it immediately at compile time. It throws a hard error saying you cannot override a final function. It's honestly a brilliant way to make sure your intended logic runs exactly the way you designed it, no matter how many child classes someone tries to build later.
Next up is Section 4, the gotcha, C++ versus Java.
Okay, pay close attention because this is the classic interview trap. It's exactly what separates the average candidates from the top tier ones. The rules actually change depending on which language you're talking about. We know both C++ and Java use final to stop classes from being inherited and functions from being overridden, right? But Java takes it one massive step further. In Java, final is also used to lock down variables. If you type a final integer variable in Java, that variable is frozen. You can't ever change its value. But in C++, the final keyword does absolutely nothing to variables. If you want to freeze a variable in C++, you have to use the const keyword. Seriously, do not mix these up during your interview.
Finally, let's wrap up with Section 5, Summary for Technical Interviews. I literally want you to grab your notebooks right now and write this down. This matrix synthesizes everything we've talked about into one simple visual. Take a look at the rows and columns. When your target is a class, both C++ and Java use final. When it's a function, again, both use final. But look closely at that bottom row. When your target is a variable, C++ uses const, while Java uses final. Memorize this. Burn it into your brain. If you can confidently explain this distinction during a placement round, your interviewer is going to know your fundamentals are absolutely rock solid.
To wrap up today's lecture, I want to leave you with a quick question to really test your architectural thinking. Can you think of a real-world software scenario where restricting a class from being inherited is absolutely crucial for security? Think about things like banking apps, cryptography systems, or maybe password managers. Why would a developer physically lock down a core class in those specific systems? Ponder that. Keep practicing your code, and I'll catch you in the next lecture, right here on Skip Uni.